Okay, good morning, everybody. Praise be to the Lord. Welcome back. We're going to have our math class. That is a review for the topic of multiplication of decimals powers by 10. Okay, so we're going to watch a video about how to just to remember how to multiply decimals in the using multiples of tens. Please take notes in your notebook. Okay, please take notes in your notebook. Right? Take notes in your notebook and please watch the video about what are you going to review.
Specifically, looking at patterns and zeros as well as powers of 10 to help us understand quick tricks when multiplying with decimals. Before we get started, let's look at some review. In the number 10 to the third, we need to look at how much is that number. So if we recall, the base is 10. That tells us we have the number 10. The exponent tells us how many times. 3 times, keyword being times. So 10 to the third is the same as 10 times 10 times 10, which is 1,000. 10 to the fourth, we've got a base of 10 and an exponent of 4, so we know that it's 10 times 10 times 10 times 10, which is 10,000 if you do all the multiplication. But we've also learned in the past that there's a quick trick with powers of 10. We know that a 10 is going to just be a 1, and the exponent will tell us how many zeros. So 10 to the third, 1 with 3 zeros behind it. 1, 2, 3. 10 to the fourth is a 1 with 4 zeros behind it. 1, 2, 3, 4. There's our quick trick for powers of 10. Down below, we know that we can use that same quick trick to help us multiply quickly. That's why we use it. In the example, we've got 6 times 10 to the third. Well, to use that quick trick, we learned that we can do 6 times 1, which is 6, with 3 zeros behind it. And we know that's right because we said 10 to the third is 1,000. 6 times 1,000, we said the quick trick is take the fact that 6 times 1 with 3 zeros behind it, 6,000. One more example, 12 times 10 to the fourth is 12 times 1, the fact with 4 zeros behind it, for a grand total of 120,000. Let's look at why that works though. In the example, 5 times 10 to the second, we know that that's the exact same thing as saying 5 times 100, because 10 to the second is a 1 with 2 zeros behind it, 1 with 2 zeros behind it. We've learned that the quick trick is when you're multiplying by powers of 10, do the fact 5 times 1 is 5, and then just put the number of zeros that are in your problem behind that number. There's 1, 2, so we put 1, 2 zeros behind it, and we've got our answer of 500. But why does that trick work? Why is that what we've been saying? Well, let's look at the number 5. We know that every single number has a secret hiding decimal behind it. So in the number 5, there's a decimal right there. In the number 500, there's a secret decimal right behind it as well. So what's going on here? Originally, the 5 was in the ones place. In our final answer, the 5 has shifted all the way over to the hundreds place. It has shifted 2 place value positions over. When we multiplied it by 100, what we've really done is shifted 1, 2 places over for that decimal. And what happens is, in those empty place value positions we've created, we put in zeros. 0, 0, and that's how we turn that 5 into a 500. In reality, the tens quick trick that we've talked about is not throwing zeros on the end of the number. What's actually happening is that we are shifting the decimal based on the powers of 10 that we have. We had 1, 2 powers of 10. Look at that, the exponent. 2 powers of 10, which gave us 2 shifts to the right. When we're multiplying, our number gets bigger, so we have to shift to the right to make the number bigger. We went from 5 to 500. So now we know why the quick trick works, and we're going to need to understand that for the rest of our multiplying of decimals. The new quick trick is not just throw zeros on the end. We shift the decimal to the right in multiplication based on the powers of 10. So let's look at this trick in action. We have the number 3 and 72 hundredths, and we're going to multiply it by 10 to the third. We know that 3 indicates 3 powers of 10. And we know that the quick trick is not just throw zeros on anymore. It's how many shifts, and we're multiplying, so the shifts are to the right. We need the number to increase. It's how many shifts to the right we're going to need. So 372, we know times 10 to the third is a 1 with 3 zeros behind it. So we can still see 1, 2, 3 zeros, 3 in the exponent, that's those 3 shifts. So we're going to take 372 and shift to the right 3 times. 1, 2, and 3. We've created an empty place value position, and all we need to do is fill in a 0 there for a final answer of 3,720. Another example. Again, the exponent tells us 3 powers of 10. We know that that is the same as 1,000. 3 zeros indicates 3 powers of 10 as well. So we know in 4 and 1/10, we're going to need 3 shifts to the right. Why to the right? Because we're multiplying, in this case, multiplying by a whole number. So 1, 2, and 3. This time we've created 2 empty place value positions. We fill in 4, 1, 0, 0 for a grand total of 4,100. There's only one more twist with these patterns that we need to look at. And to help us understand it, we're going to look through some patterns first. Here, you can see that with each number, the power of 10 is increasing from 1 to 10 to 100, 1,000, 10,000. Every time we're jumping up by 1 power of 10. So we're going to multiply all these numbers out, and we're going to look and see if we can figure out a pattern. 6 and 87 hundredths times 1, well, even though we're multiplying by decimals, the identity property does not change. When we multiply by 1, it's exactly the same as what we started with, so 6 and 87 hundredths. In the next one, by 10, that's another power of 10. 1 shift to the right, 1, 0, 1 power of 10, 1 shift to the right. So we get 68 and 7/10. In the next one, 100 is 2 powers of 10, that's 2 shifts to the right. 687. In 1,000, we're up to 3 powers of 10. 1, 2, 3 zeros. That's 3 powers of 10 and 3 shifts to the right. 6,870. And in the last one, 1, 2, 3, 4 powers of 10. 1, 2, 3, 4 shifts. 2 empty place value positions in this case. Gets us 68,700. So looking at our grand total now, we can see that every time the power of 10 increased by 1, it was 1 more shift to the right from our original number. Our original number was 6 and 87 hundredths. Every time the power of 10 increased, it was 1 more shift to the right. 1 more shift to the right. 1 more shift to the right. Each time we increase the powers of 10, we shift to the right 1 more time. Now let's look at what happens when we're having a decreasing pattern of powers of 10. This time our original number is 9 and 38 thousandths. And we're going to multiply it by, well, this exponent just tells us that there are 4 powers of 10 this time. So, just like we did before, we're still going to shift to the right because we're multiplying. When we multiply by a whole number, especially a big whole number like 10 to the 4th, our original number needs to get bigger. So we have to shift to the right to make it bigger. How many shifts? 4 shifts. 1, 2, 3, 4. We've created an empty place value position, and we'll fill that in with a 0. We get 90 Now, our next example has 3 powers of 10. So we're multiplying by a big number. 3 powers of 10 is still pretty big, which means our numbers that we started with, 9 and 38 thousandths, also needs to increase. It's just going to increase 1 fewer place value positions than 10 to the 4th. We're multiplying by a little bit smaller number than we did the last time. Only 3 powers of 10, 1, 2, 3 place value positions over 3 shifts, and we get 9,038. So now we move on, and we've got 2 powers of 10, which means only 2 shifts to the right this time, still increasing, but just 2 shifts. So 1, 2, and now we're into 903 and 8 tenths. And so we continue on. Now we're down to 10 to the first, which is 1 power of 10. That 1 power of 10, because we're multiplying, is just 1 shift to the right, which gives us 90 and 38 hundredths. And then lastly, we know that 10 to the 0th is not a power of 10, actually, it's just 1. That leaves us with 9 and 38 thousandths times 1, which is 9 and 38 thousandths, no shift. So as you can hopefully see, we can use the pattern here to help us understand what's going to come next. Every time we were multiplying, so when we applied the trick, we shifted to the right. But every time we went down the pattern, we decreased by a power of 10, and it was 1 fewer shift to the right every time. So from 4 down to 3, down to 2, down to 1, down to 0 powers of 10, it was 1 less shift to the right. And it almost kind of looks like we shifted to the left a little bit. So in 4 powers of 10, to get to 3 powers of 10, we shifted left. Got us 9,038. In 3 powers of 10, if we shift it to the left, that gets us the value of 2 powers of 10. In 2 powers of 10, if we shift to the left, we get that value of 1 power of 10. And one last time down to the no powers of 10, we end up with a decimal right back where we started. We can use this to help us understand the next problem. Again, we've got a decimal number, and we're multiplying it by powers of 10. 100 down to 10, down to 1, but after the 1, those don't really look like powers of 10, but they are. If the pattern continued, we'd go past 1 to 1/10, to 100, and to 1,000. They do count in the powers of 10, and we can use the patterns to figure out what the value of 8 3/10 times 1,000 is going to be. So let's start with the ones we definitely know. 8 3/10 times 100. 100 is 2 powers of 10. So that means because we're multiplying, 2 shifts to the right. 1, 2. Gives us a value of 830. We move on. 10 is 1 power of 10. That's 1 shift to the right. 1 shift to the right gets us 83. 1 does not count as a power of 10, and the identity property tells us that anything times 1 is the same as it was, so that's going to be 8 3/10. Now, let's look at the pattern. When we had 2 powers of 10, we had a number of 830. When we drop down to 1 power of 10, it's kind of like we shifted to the left from where we had started before. That got us 83. When we jump down to no powers of 10, it's kind of like we shifted to the left. Look, we got 8.3. So when we have 1/10, every time we decrease by a power of 10, it's 1 less shift and 1 kind of like a shift to the left. And that's what we're going to do here in 1/10. 8 3/10 times 1/10 is actually going to cause us a shift to the left. Gets us 83 hundredths. And you might say, but you said when we multiply, we shift to the right. Yes, when we multiply by a whole number power of 10. If we're multiplying by a decimal power of 10, we are going to shift to the left for our quick trick. 1/10 is 1 decimal power of 10. If we continue on down to 100, it is 2 powers of decimal tens. So in this case, it's going to be 2 shifts to the left. 1, 2. We fill in the empty place value position with a 0. 83 thousandths. And then in our last one, 8 and 3 tenths times 1,000 counts as 1, 2, 3 power of decimal tens. That's going to give us 1, 2, 3 shifts to the left. 83 ten-thousandths for our final answer. Now it's time for you to try some examples. We have 2 patterns with powers of tens that you are going to go through. You are going to find the value for each power of 10 multiplied by the decimal number. Show your work on another piece of paper and pause the video here while you find your answers. When you're ready to check your answers, unpause, and the next slide will have the answers for you. All right, let's look at the answers to number 1.
Okay, everybody. Okay, so we already saw how to make or how to remember how to multiply or how to make a multiplication with decimals using patterns of equivalent in 10. Okay, powers by 10. So remember, this is just a review, people. This is just a review. For the next class, we don't have the classes because I will send the exercises. Okay, I will send the exercises. So let's try to make some examples in our board, right? We're going to make some examples in the board to see how to make a multiplication. Okay. So, for example, if we have 2.06 by 1.74, we only have to start to make this as a normal multiplication. Okay, for example, 6 times 4 is 24. I have 2. 4 times 0 is 0, plus 2 is 2. 4 times 2 it's 8. Now I have to multiply the 7. 7 times 6 is 42. I take 4. 7 times 0 is 0, plus 4 is 4. And 7 times 2 is 14. Right now I have to multiply the number 1. 1 times 6 is 6. 1 times 0 is 0, plus 0. 1 times 2 is 2. So I have to add. I have 4, 4, 18, 5, 3. How many numbers I have to count to get the period, the point? In which part I have to put the point? So I start to count. 1, 2, 3, 4 in here. So my answer is 3.5844. I have to count 4. 1, 2, 3, 4. The period is in here. 1, 2, 3, 4. Okay. Do you have any question? Do you have any question, people? Make your questions. Yes, Dana. Do you have a question?
Mister, why you uh, put the point after four numbers?
Why? Because if you see, I have the period, okay, before two numbers in here in the first one. 1, 2, then the second number, 1, 2. So in the final result, I have to move it, the total of all the numbers, okay? 1, 2, 3, 4, 1, 2, 3, 4. So it's 3.5844. Do you have another question, people? Okay, let's try to make another example. I have 3.19 times 0.78. Try to do it by yourself. Don't use calculator. Try to do it by yourself. Try to do it by yourself, and please on the chat you have to give me the final result. Right, Jimena? Stop eating your earphones and start to work. Bless you. Start to work, Jimena. You finish, Felix? You even start to work. Nice. Are you in classes, man? Or you're not in classes? Let's see, Felix, work. So a lot of you said the answer is 2.4882. One of you said 1.0882. Another one said 0.5742. One of you said 2.4. Another one said 23.6382. My goodness. Another one said 2.4982. So let's see the answer. 8 times 9 is 72. 8 times 1, it's 8. Plus 7, 15. Get 1. 8 times 3, 24. Plus 1, 25. Multiply the 7. 7 times 9. 7 times 9. It's 63. Get 6. 7 times 1 is 7 plus 6, 13. Get 1 again. 7 times 3 is 21 plus 1, 22. Then all of them is 0, so I don't need it. So I have to add 2, 8, 8, 4, 2. How many times I have to move the period? 4. So the answer is 2.4882. So people, okay, let's see. Let's see. Diego Guardiola, you have a question. Where are you? Ah, here it is. You have a question? No? Okay. Ah, because I saw you raise your hand, so for that reason I think you have a question. Okay, people, this is only a review. I will send the pages for your work for today. Okay, you did math. So I don't know if you have any other question. You don't have any question? Okay, guys. See you at 11:20 for grammar. Okay? See you at 11:20 for grammar. Be punctual.